My name is Senyk. I'm working since nearly 3 years in the Qt team in Munich. I'm a customer service engineer. I'm helping external customers to succeed with their Qt project, helping them in various areas, mainly in the embedded sector. The two businesses we are mainly active in are the home media sector, so Qt on your TV, and the IVI sector, Qt in your car. Yes. Background about this talk. This talk originated from a project we did internally, the Qt Media Hub. It's our common demo for shows, and one of the main reasons for it was, when we started it, was we wanted to see how Qt scales. Back then, all we did within the Qt development framework was small examples, graphics examples, no real big applications. So Qt Media Hub was intended to give us the possibility to gain some experience with larger scaled applications. The setup, the idea behind it was to copy XBMC, to make a re-implementation of that in Qt. XBMC is an open source media center. A colleague of mine used at private, Donald, and he had the idea to create the same thing, using the same assets, using the same images, but in Qt and QML. We learned a lot during that with this project, and most of the things I'm going to tell you are originated from that project. We did a lot of mistakes. We were also fairly new to QML when we started, and most of the things are coming from that project. Most of the advice and tips I'm going to give you. The agenda here is explain you a little bit how we see the world, how you should design and architecture your QML projects, large-scale QML projects and applications, and also give you some tips about where the tweaks and so on to give you better QML experience. Question for you: how many of you have already written like a few lines or more QML? Okay, not so much. That's not so good. This talk is intended to be a more advanced talk. I know my crowd now, so I know that I have to explain one or other thing a little bit more in detail. If anything is unclear, if you have questions, raise your hand. You can ask anytime you want. Already some questions? Okay. Again, if you have questions, I try to make breaks and ask you for questions, but I tend to be a little bit fast and to rush things. Just raise your hand. I will stop and ask you for your questions. So QML is a new language. Okay, nowadays not that new anymore, but it's a new language, and its feature set is intended to be limited. That's not by laziness, that's by design. You don't want to have every possibility and everything you got in C++ and your QML for various reasons, and I'm going to go to a few of those reasons in my talk. But that's not a problem. The thing here you want to do is combine your QML with C++. QML gets really strong if you combine it with C++ and extend the functionality you need with C++. It's very easy. There are a couple of very easy ways of extending QML, talking between QML and C++, combining them, and so on. And yes. One of the first questions you got when you create your application and you start your development is, how much should we do in QML and JavaScript? So QML is JavaScript based, right? So you can make QML, and you can write in your QML, you can write as much JavaScript as you want. And the natural question here is how much QML do we want to do? How much JavaScript do we want to do? And how much do we want to do in C++? When we started with Qt Media Hub, we thought that solving all problems in QML is a good idea. It's not. We tried to have every thing which can be solved in JavaScript be solved in JavaScript. Also a lot of business logic and also some heavy lifting, some data processing and everything. It's not a good idea for various reasons. The first one is you ruin your QML code. You have a lot of things in there which don't really belong in there. And it's getting very complicated in your QML code. That's the first reason. You will only understand that reason if you write a big application, and you will see that the JavaScript code gets, and QML code gets more and more unmaintainable. The second reason is in the embedded sector, performance is a big issue, and JavaScript is by far not as fast as C++. JavaScript gets faster and faster over time. Google and Apple and everybody invests in their JavaScript engines, but anyway, it will never be as fast as C++. So yeah, those are the main two reasons. So what we found out is what's a good way of looking at it is that your C++ is your runtime. Girish said in his talk that you can also look at it as the operating system. I don't like that view that much because I'm not really getting it. But if it helps you, take a look at it as your operating system. I, for myself, see it as everything not visual, everything business logic, getting your data, everything which is not painting pixels and moving images around is my runtime, my C++ runtime, and I put everything in C++ as much as possible. This has a lot of, it helps in a lot of cases. One case, or one thing is that QML tends to be not as reusable as C++. You can create components, you can create reusable code, and that's important to do. I'm coming back to that later. But JavaScript tends to be a little bit harder to maintain over time, especially if you're new. Where C++ is really, as all your Qt developers, you know C++. C++ is, you write it once and then you're good forever, hopefully. So see QML as your presentation, see QML as your visualization of your data, of your controls, and all that. If you do that, if you look at it that way, you will very easily and very fast come to the conclusion that it should be one-way traffic. And with one-way traffic, I mean QML depends on C++, never the other way around. If your C++ ever depends on your QML, you have a problem. We had a big problem there because in our project we have multiple skins. If you take a look at that slide again, I haven't explained that good. So we started to copy one skin from XBMC project, their main skin, the Confluence skin, and we did another skin called a colleague of mine did a skin for him privately, so he can use it at home. The Dolphin skin, and nowadays we have 6 skins. We have an IVI skin, we have like a low virtual testing skin, and a few more. And if your C++ depends on your QML, you have to implement the same functionality, the same logic, the same architecture, however you depend on it, in all of your skins. And that makes things very, very complicated and nearly unmaintainable. And as soon as we realized that, as soon as the day we encountered a situation where we had to copy the code from one side to another side because the C++ depended on it, We throw everything in that area away and did it the right way. So again, if you're doing it this way, if your QML depends on your C++ runtime, you can easily extend your application with additional skins, additional UIs. You might think, okay, by just implementing application with one UI, why would I care? If you ever come to the situation that you have to deploy that to another type of device, as you're coming from the desktop and want to have the same application on a mobile phone, or other way around, or even if you go from a mobile phone to a tablet or something like that, you very, very quickly want to rewrite your, or at least a little bit rewrite your UI, and there you go, you're screwed if your C++ depends on your QML, because you have to implement the same thing again. However, C++ depends on it. So a few sample rules: don't ever access QML UI elements from C++. There are a few helpers to give you the possibility to access and interpret QML in C++. The main two ones are declarative expression and declarative script string. Try to avoid them. If you're using them, you're probably doing something wrong. The only use case I know which they are really helpful and good is for unit tests. If you write unit tests in C++, you want to access your QML to test the user interface. But I think that's really the only situation where you should use them. With that approach, it's not interesting for everybody, but we in Qt Media Hub, we thought about it a couple of times to write the UI in a different technology. For example, so write the skin in a different technology, for example, HTML. We haven't done it so far, but our architecture is fit for it. And again, if you keep the approach, C++ never depends on your UI, then you should be able to do that very easily. Any questions so far? Okay. Is the speed okay? Okay. So again, there is always a situation, you will encounter a lot of situations where you want to extend the functionality of QML through C++. That's what you want to do. That's the good thing to do. There are basically two ways. The one way is to register a type, register a class, and then create that class in QML. The code is not very important. The only two things important on the code are QML register type is what you want to remember if you want to do it. And the other thing is, what you have to understand here is that the object is created in QML. So in C++, you only register the type, the class, and the object, the instance, is created from within QML. That's very important because if you do it that way, QML controls the lifetime of the object. And that's what you want. Because it's very hard for the C++ to understand and to know when and when not the QML is going to need that object. So again, it's the same thing here. As I talked to you just before, the C++ shouldn't depend on QML. And for a lot of objects, it's going to be very, very hard for the C++ to understand how long do I need the object, when do I delete it, when not. The other way you can extend it, the opposite way, you create the object in C++, and you can inject that. You can get the root context and then set the context property with a name and the object, and then you can use that in your QML. Two things about that. It's not the preferred way. You should only do that for certain cases. And second of all, there's a little trick I'm going to show you a little bit later, tell you a little bit later. You don't want to set more than one context property. There's a very easy way to have only one context property. That's what you want. I'm going to tell you that a little bit later. The sample rules are here. Register type as much as possible. Avoid injecting context properties. because the lifetime is going to be controlled by C++, and only if this is really, really, really what you want, you should do that. And the main use case for it are singletons. Singletons are not the best pattern anyway. So if you avoid singletons, you should be able to avoid context properties as well. Okay. So if you write your C++ classes, you want to register your 3 main friends or your 4 main friends. It's QProperty. QProperty is a macro where you can add a few things. Some of you might know it because they don't know QML that well. It's in your class, in your C++ class at the beginning, you have the QProperty macro. You give him a name for that property, normally always a getter, most of the time a setter, and a notifier, a signal, and then you can use that property as any other property in QML. Signals and slots are your friend. You need them for QProperty anyway. And QInvocable. The difference between QInvocable and slots is a little bit vague. At the backend, at the Q implementation level, it's the same anyway. Small sample is QInvocables can have a return value, QSlots not. That's the main difference here. There are different use cases, but it doesn't really matter which one you use. For properties, you need slots. Yeah, and if you want to return something, you need an invocable. So here you can see the green one. It's not very, so the one after the dot. That's one of the QProperty macros I told you. You can already see here, you give him a type, the name, then read. After read comes the function name of the getter, the getter. Then after the write, the function name of the writer. And the notifier is the signal, which you can emit into C++ if the property changed. You have to emit if the property changed. To tell QML, okay, something happened, I have to update my bindings and whatever. So yes, notify is very important if you want to bind against a property. Sometimes you don't have that really, because the property is not changing. Then you can use the constant. Because if you don't have a notify, that's okay. The compiler will not complain. But if you bind against that property in QML, so you write, you have a property like here text, and in QML you want to display the text and bind that there's an element which displays text. It's also called text. And if you set there the string to display to that property, and you would not have that notify here, that's gone, then he would complain that you bind against the property which has no notify. Because he knows it's not, there's no signal, I can never update that, and therefore it's the constant to remove that warnings, basically. Final is, as far as I understand Java, the same as in Java. It basically tells the mock object that the property cannot be shallowed. So you cannot have the same property in a subclass, not in C++ and not in QML either. So that helps if you have a property like X or Y. You never want to shallow X or Y in most cases. So if you know that should never be shallowed, you can use final. QClass info is a little bit more complex. I first have to explain a little bit about the QML engine itself, the declarative engine itself. QML and declarative is all about property binding. For those of you who have written QML, you've already done QML binding and you didn't know, you have already done some kind of binding, but you haven't know it. If you write an element and you have a child element in there, that's also property assignment. Doesn't look like that because there's this feature, the default property. The default property is the one if you just add childs, just put things in your item, then they will default-mäßig be added to the default property. And you can set that. So all the childs, all the things you write within the element will be assigned to the default property. Yes. Is that clear? If not, you can tell me. Okay, nobody complained, so I guess it's clear. Yeah, QEnums are really easy to use. There's a macro for that. It's easy to use, not much to tell about it. Use it. If you, for example, have like anchor.left or anchors.right or right margin and everything like that, that's implemented using a pattern called property groups. In a property group, you have one property, and this property has additional properties without any like real backends, real features. It's just a container, a union, if you want so, and it helps organizing your code and giving it a little bit structure. And examples are the one everybody has used to have written QML is the anchors example. There are two ways of writing two syntaxes. It's either that one with the brackets, and you can set all the properties you want. You don't have to set any, but whatever you want to set, you can set there, and the rest gets the default value. And the other one is the dot. So style.ret, style.framewidth, and so on. So yeah, it's the same thing, just different syntax for that. Yeah, again, it helps organizing your properties. If you have 10 properties which are all part of the same thing, more or less, like, again, anchors, you want to use that to have some structure. Yes, the declarative engine has one limitation. It cannot interpret multiple signals with the same name. It will only read the last one. Avoid that absolutely. If you ever expose a type to QML, try to have only one signal with the same name. If you have multiple, you're going to be in trouble because nobody really knows what's going on. And there is no guarantee which one he's reading. At the moment, it's the last one. Who knows what it's going to be in the execute version. Avoid qvariant. It's not always possible to avoid qvariant. There are some C++ classes for declarative which actually force you to use it. But in general, try to avoid it. Girish had an example in his talk I never saw, but he claimed that he once saw an error where, like, foobar is an unknown color error, although he never used this qvariant in any color perspective. That's because that can happen because qvariant needs to be parsed to different things, and he will try different things. And one of those parses is to parse a string to a color, so the string blue to the color blue. And he somehow ended up in that parse. I have no idea how. In general, the reason for avoiding it is if you're as specific as possible, as type safe and as specific as possible, the declarative engine will be able to make the most out of it, to do the fastest thing possible, to get this as precise as possible, makes it faster. Okay, I I guess no questions so far? Okay. QList, and for example, QStringlist is one implementation of QList, can be used in QML. Just have to register that. Oh. Yeah, you have to register the type. It's okay, you can use it. You just have to be aware of that this has a very hard limitation. The limitation comes from the fact that QList itself is not a QObject. So QList itself cannot have signals and slots. Because it cannot have signals, it cannot tell the declarative engine if anything happens. So if the C++ enters a new, or even the QML, enters a new element to the list, or removes the element, clears the list, whatever, it cannot notify. So it cannot tell the engine that something happened, so the engine will never know that something happens. It might be as simple as that you display old data. It might be as critical as that you access data which is already deleted, which gives you a segfault. It's okay. It's still okay to use QList as long as you're aware of that limitation. If you can't live with that limitation, in most cases you don't want to, there's the QList property, QDeclarative list property. It's kind of a wrapper around QList, which adds all the functionality you need to use it as a proper list, as a proper model within QML. Basically gives signals when something happens in the list, more or less, and some slots in the vocabularies to be easier usable. If a component gets created, it takes a while, and it needs to be parsed, it needs to be allocate memory and everything, and then it have the initialization of all the properties. And if that all is done, there is a slot, there's a virtual function you can re-implement. It's called component complete. It will be called if the component, the object you have registered and then created in QML, is finally fully created. And that's important if you want to have some late initialization things happening. Not for the startup, you can do that in the, not for the initial setup, you can do that in the constructor of your C++ class. But like if you want everything is assigned and everything is binded and now you have to take one of the properties to do some initialization here, then you can do that in the component complete. The only thing you need to remember is you have to add, you have to subclass declarative parser status as well. It's a fairly small class. I think it's only a few virtual functions. Declarative property map. I told you before that you should try to avoid injecting properties into your root context. You shouldn't avoid that. You should avoid that if possible, and if it's not possible, try to only do one. And that's where declarative property map comes in place. The declarative property map, what it does is it's a template map, a template class, it's a map. And the key here is always a string. And the value can be, the value is a variant, a Q variant. So you can insert a Q object, for example, and give it a name as a key. And that name is then accessible in QML. So we in QML, for example, we have a declarative property map called runtime, which has all the singleton classes and resources and all that stuff we want to inject. Holds that because it's a declarative property map, and we've, for example, insert a class of type settings, and with the name settings, and then in QML we can access that with runtime.settings. It's a very powerful thing, and it's very helpful. Use it, especially for your root context. And if you inject properties there, because again, if you add um, 100 different properties into your root context, nobody will know what type of properties there are, where they come from, and everything. They will just horrible pollute your namespace there. So capsule that into your property map, and things get get easier, both on the QML as well as the C++ side. Yeah, general advice, try to think declarative. Thinking declarative only is possible if you write QML, if you write the declarative code. Property binding, property binding, property binding. You can make a lot of errors in property binding, but in general, it's safer than any other pattern or approach you can do. If you do something wrong, you normally get a warning, and it's very easy to profile and everything. It's really helping. The best thing about it, it keeps your code clean and very readable. That's basically the main thing here. States and transitions, use them, but be aware that state machines can be a complex thing, and you shouldn't overdo it. Don't have a state machine with 100 states, and in each state you have a 2-line long Boolean expression to decide if it's the right state or not. We had that in the stage where we put as much as possible at the beginning, as much business logic as possible in the QML. We had state machines with, I think, already 6 or 7 states was unmaintainable because you already had like 4 or 5 different parts of the Boolean expression, and it made things to add another state, to add functionality. It made it very, very complex, and you had to spend a whole day just to try to understand the state machine yet again, to add one other state, and next time it takes you 1.5 days. And try to limit yourself. One good thing I experienced is if you have one property which defines your states, you can do as much states as you want. If you have, for example, I have an example, it's a mock-up, but a good example. I had an instrument cluster, and I wanted to display the shifts. The shift which is in the gear, which is currently active, and I did that with states. That's fairly okay because I only had one property, and it was always just a very, very short expression, and they were very easy to maintain, those expressions. No collision, no overlapping, and all that. One bad example we had, where the one I just said with the 5 states, was a media player. You have play, you have pause, you have forward, you have different forwards, so different speeds. You have backwards, you have paused, you have stopped, and that all depends on different properties, more or less, and it makes things complicated. At the end, what we did, moving that business logic and moving all of that to C++, things became very easy, very maintainable, and it's less code and better to read. Although QML is a different language, and in some areas you want to do it differently a little bit, don't forget your C++ lessons anyway. Encapsulating and data hiding is a very good thing, especially if you write components. For example, in that picture, there are components is a little bit overloaded word. I use it anyway. We have here 1, 2, 3, 4 components. We have a background image. We have like the header thing here. We have the menu, and we have that thing here. Each of those are put in their own file to keep things separated and to encapsulate things and to be able to encapsulate things, data. Yes. Interfacing on each other's thicknesses. Lots as usual, as you do it in Qt C++. Yeah. Data hiding. Oh no. Yes. One slide in the middle. Anyway. This is code structure. It's copied from the Qt code. You don't have to follow exactly that approach, although that tends to be the right one. But what you want to do in your project, follow one structure. If you don't like that, decide on something else, but decide. Have a code structure. If multiple people work on a project, it helps a lot if they don't have to scroll around for 5 minutes to find something. Makes your project way more efficient. And you don't overlook things. You don't overlook functions. You don't overlook properties if they are structured in that way or in any way. We think that's the right way, but it is not necessarily the right way for everybody. What you can see here a little bit is with acceptance of the ID at the top is the public stuff which can and should be accessed by someone using your component, using your file, using your item, and on the bottom are the internal implementation stuff. That's kind of what Qt Development Framework thought is the right thing to do, and we follow that in QML most of the time. We are humans as well, so not always, but if you don't follow it, eventually someone will be angry and someone will overlook something and waste a lot of time with that, and then he will correct it. Dynamic scoping is, so scoping itself in QML is relatively complex. I don't fully understand it, to be honest. Dynamic scoping is one of the aspects of it, which is relatively simple and dangerous. Dynamic scoping basically means if you access something, if you write down, in that case, a P there, he will look around him in his scope. Is there a P? And if not, then he will look at his parent scope. And he will look around, and if your parent doesn't find anything, he will go up. And up to the topmost item. I'm not 100% sure why this is in QML. It's dangerous, and unfortunately, you will not be able to turn it off. I hope that sometime in the future and new release you can turn it off, but nowadays you can't. This code is very evil, and if you write such a code, you are evil. But sometimes it happens that even if you're not evil, that you end up with that code, and that happens to everybody. You write a QML component, and you write, add functionality, and eventually you will realize, okay, now it has a few hundred lines of code. I have to strip out some of this to a separate file. And I want to move that to a separate file because I have an area there, like in the picture before. At the beginning, maybe you put everything in one file. Eventually, you think, oh, okay, the menu can be stripped out. And then you move the child item, one part, into a separate file, and you still have that code in there. That happens. Okay, to explain you the code a little bit, maybe. I think I forgot that. So what happens here is the child needs an interval for its timer, and he normally gets that from its parent. And in the past, this was written down here. This was called item, and all the code over there was here. And he accessed that property via p.duration, which is absolutely fine. And then somebody, maybe you, moved that code over to its own file, and then it's still that expression here. That happens. The problem with that is not that it happens, the problem is that it's still working. It might not, it won't work the day you move your child over. It might not work the day after because somebody changed the parent or used the child in another context. So somebody renamed the parent, nobody was aware that you used the name of the parent over there, and it's crashing, or it's not working anymore, or you have strange behavior. The thing to solve here basically would be to have a property here called interval. It could be its own property or an alias of that property, and then it's be set here. So here would be interval dot and then duration, equals duration. Okay. Yeah. Qualifier property access with ID means you can access properties without the ID. If, for example, your parent has a property, you can access that without the ID. Avoid that. It's very, very dangerous. Makes your code unreadable. Be careful what you import. I don't think that's very careful. That's very dangerous. Gears think it is. For example, if you import WebKit, WebKit will be linked and loaded. But besides memory, waste of memory, it's not very dangerous. And if you don't use it, you can remove that later if you're doing the profiling or something. So be aware that don't import everything. On property changed is not called on startup. Means that you bind your properties, and when a component is created and you implement the on property changed slot, it will not be called when the component is created. Therefore, you have component on completed. The same thing you can have as a virtual function, subclassing a virtual function in C++. You can implement the slot here in QML. Same thing, you can use both or one or the other. Don't copy paste similar code, keep components. Yeah, so you can write components, you should write components, but limit yourself. QML is not C++, and you do not want to make the magic all-solving button or even random component in QML. You want to write simple things. The reason for that is mainly you can write QML very, very fast. And the second one is that large QML files tend to be harder to read than large C++ files, for example. Keep it simple, make an image button, make a text button, make a checkable button, and make 10 buttons instead of making one magic button. It helps reduce your code size, basically, and to keep things simple. Some of you know maybe the Qt C++ internal code. We use a thing called dpointer, private pointer, or however it's called officially, I have no idea. It's basically more or less the same thing here. You can just create a Qt object as your child and name it a D or whatever, and put all the properties you don't want somebody from using your component accessing that properties. A lot of properties which you need for your work, for your logic, for your visualization, but you don't want anybody using your component to change them because they're dangerous, because the user will destroy the functionality anyway, and that approach is very good here. State groups, very useful. Again, if you write a component which is used by a lot of people, some of those will try to have states for your component. They will add a state, but you have already implemented a state for that component. And then things get mixed up, and they get destroyed and shallowed and everything, and that will break down eventually. Therefore, the state group's original intention was a different one, but if you write the component, it can be very useful. Instead of having the state properties like the states and transitions, you can just add a state group child item, and it has the same properties to access and to use that in your component. And then when somebody uses your component and adds in his code, in his application code or whatever, adds states, then there's no collision at all. Implicit width and height, a little bit hard to explain, I think. In general, you have different perspectives of width and height. The actual width and height, and the one you want the item to be. And they differ for various reasons. For example, animations, or because of component or whatever. Implicit width and height are like storage to put the intended width and height. So for example, it would be, for some use cases, for an image, it would be the size, the size of the source file or something like that. But yeah, you can use that in your components. Children rect is helpful. It just calculates the bounding rect of all your children's and sums them up to the whole children rect. Default keyword is the same as I told you in this plus with the class info default property. You can do the same thing in QML. The Qt Components project has some very good ideas and some good implementations. Take a look at the code if you're interested in more patterns. Pragma library, I'm going to be a little bit faster because we don't have much time left. Pragma library basically means if you input a JavaScript library, what normally happens each time you implement that, it will be loaded, an object will be created, and each of those imports live on its own. If you have a big library, that can be a waste of a lot of memory. Pragma library helps you, that's a JavaScript line, helps you to, it will only be loaded once in the whole runtime, in the whole application. And there are some limitations to it. If you use it, if you need that, look it up. One thing in general, if you use JavaScript, the global code runs in a limited scope. Actually, it runs in the same scope as all the other JavaScript parts. But the problem here is that the first thing in your QML file are the imports, and also the JavaScript imports, JavaScript file imports. And if you import at that stage, nothing is created in your QML file yet. But the JavaScript file will be one of the first things which will be created. And one of the first things in the JavaScript file is that your global code is going to be executed. For example, that X is going to be trying to evaluate and try to assign the value. That's not working because QML item is part of this QML file. You have imported this thing, and it's not created yet. If you need initialization and all that, use component non-complete again and just call some initialization function JavaScript. At that point, everything will be created, and JavaScript file can access your QML items. I'm going to skip that because it's a little bit hard to explain. It takes a little bit, and we don't have much time. If somebody is interested in custom structures, you grab me later and ask me. Basically, why you need it if your data is so complex that you don't want to expose that to your QML. Like a huge table with artists, audio, like with audio files, there's a lot of stuff in such a table, and you don't want to expose everything and take care in QML about that. You want to take care in C++, and we found a very nice way to do that. If you're interested, ask me later. Right. As a delegate, you're in your delegate scope. You have attached properties. Actually, you have multiple attached properties, and one of the important ones is model. So if you write the delegate for a list view, for example, or a grid view or path view, in that delegate code you have a property called model, which gives you the possibility to access your data. So your delegate is about an artist, and you have the name, the birthday, and whatnot. And that all those in C++ or in model view context is called display role or role, and all that roles and display roles are stored in that attached model property. And this is normally not accessible because of the delegate scope thing from outside, but sometimes it's important to access. For example, in the code down here, you want to access the current item and the name of that. And if you need that, use a property alias. If you can see here, that little line here helps you to access the model from outside. Just a scope thing. It's not enabled per default because it's, again, data encapsulation. The default thing should be it's not accessible, but sometimes it's necessary. I will not talk much about that. There are a lot of talks, and if you're interested in that, go on our website. All the talks from this year's Dev Days and last year's Dev Days were recorded. Setting up your declarative view is very, very important. In most cases, and especially in embedded segment nowadays, you want, for example, to have everything drawn by OpenGL. You have to set up your viewport with set viewport new OpenGL with new QGL widget. Additionally to that, there's a lot of different flags you can set and unset, and it's a little bit complicated. They're hard to understand, and not all of them are 100% system independent. Some of them tend to be, especially in the OpenGL case, be different on Windows or Linux or Mac. It's a little bit hard. Those flags are for accessing things from the outer world and changing the actual window properties and everything like that, and they can't be 100% system independent. Yeah. Any questions so far? We have 10 minutes left, or like 9 now. It would be Q&A now. If you have questions, you can ask me now.